So it's a pleasure to have Professor Ravi Kumar to give up a talk today. Professor Ravi Kumar is Vice President and Deputy Director of Research in the Federal Reserve Bank of St. Louis. His research field of macroeconomics, economic development, income distribution, and public finance. His today's talk is Measuring Openness to Trade. Let us welcome him with a big hand.
Thank you very much for the kind introduction. Thanks also to the organizers for inviting me. I should also thank them for the picture that they chose of me to put in the program. It's been a long time since I looked that young, so they must have picked it from the previous century or something. So anyways, I want to talk about measuring openness to trade today. It's joint work with Mike Waugh, who's sitting in that corner. So the big questions we're after are sort of the standard and old questions in trade. How open is a country to trade? How large are the welfare gains from trade? These are very old questions, very important questions. And we're going to make a step of progress in that particular direction to see how far we can go. Okay, so the old approach to answering this question was thinking about measuring openness to trade via some measurement of volume of trade, say something like imports to GDP. So if my imports to GDP is large compared to yours, then I'm more open, more goods are flowing into my country. So that would be a way of ranking openness to trade. The other way is sort of a measuring some notion of barriers to trade, tariff rates, non-tariff barriers, quotas, and find a combination of those to figure out what are the restrictions to trade in my economy versus yours, and that's a way of thinking about openness. So more recent approaches with the new class of trade models, people have calculated sort of the welfare cost of autarky, so to speak. So I'll explain that in more detail once I set up the model. So in a recent paper, Arkalakis, Costino, and Rodriguez-Clare is an example of what they did. So they wanted to calculate what's the observed change, start from an observed equilibrium, and what would be the change in welfare or change in income as you go from that equilibrium to autarky. And they came up with a very simple formula. So I got to introduce you to some trade language over here. So lambda II is what the trade guys call the home trade share. So what's a home trade share? Imagine each person in this room represents a country. We are trading a bunch of goods with each other. I'm incurring expenditures on goods coming from your country. I'm incurring expenditures on goods that I produce myself. So take all the expenditures, and the fraction of those expenditures I spend on the goods that I produce is called the home trade share. So this home trade share, as you can see, has the meaning in the sense that if I'm completely closed, by construction, my home trade share has to equal 1. So lambda II would be equal to 1. If I'm open, well, that depends on what the rest of the environment looks like, and we'll get to that. So what they did was did the welfare cost calculation. The beauty of this calculation was it depended on observables, number one. So we have access to measuring the home trade share, and an estimate of the trade elasticity. So theta here picks up the trade elasticity. So we have good estimates of the trade elasticity. So you give a researcher basically an estimate of trade elasticity, open up the Penn-World tables, look at the home trade share that you can infer from there, and you can compute what's the welfare cost for country I. So lambda II is the home trade share of country I, and you can do this for all the countries. Okay? So it depends on observables and a simple estimate of the trade elasticity. Okay. So a couple of inferences that they came up with. If you look at the home trade shares in the data, the implied welfare cost of autarky is very small. So what does that mean? So a lot of the countries, their observed equilibrium, the current state, the current amount of trade, looks very close to having a home trade share equal to 1. Okay? They're very close to autarky. So now if I take that metric and ask the question, okay, let me rank these countries based on welfare cost. So the countries with very low welfare cost are the ones who are awfully close to autarky. The countries with large welfare cost are farther away from autarky. And I can rank them, okay, so the countries that are very close to autarky are close, more closed than the ones which are farther away from autarky, and I can rank the open. So that's the top 10 list of open countries, according to this welfare cost of autarky measure. Now, I don't know how good your guesses would have been, but if you had asked me, okay, name the top 10 open countries in the world, 80% of my guesses would have been wrong. I would have probably guessed 2 out of the 10 on this list on a good day. Okay? So this is sort of problem number 1. Is something wrong with this picture where this ranking of openness gives you this top 10 list of countries? The other way to think about this is that what is this welfare cost of autarky good for anyway? This is supposed to give you some measure of, had I removed all the trade frictions, if the countries were fully open, these countries would gain less compared to other countries which are much closer to autarky. These are the top 10 most open countries. If you make them fully open, they're going to gain less compared to the other countries which are much closer to autarky. That's sort of the welfare cost of autarky ranking is going to produce. So here is another way to see this. So if you look in the data, so I picked 2 countries, Malawi and the US here. You look at their home trade shares in the data, they're practically identical. 80% versus 81% home trade share. So then according to this welfare cost of autarky measure, you would declare that Malawi and US are either equally open or equally closed, whichever phrase you want to pick. It also tells you that if you make both of them fully open, then the gains to Malawi and gains to US are going to be the same. Okay? So it's that last inference that we are going to take issue with. That's our point of departure. Okay? So we're going to argue that this measure of openness, or thinking about welfare gains to trade based on notions of welfare cost of autarky or volume of trade, import to GDP, this kind of notions, doesn't actually tell you much about what's possibilities for different countries. Okay? So what we're going to do in this paper is think about a new measure of openness that's based on potential gains to trade. That is, we truly want to think about if these countries were fully open, how far can they go? Now, if I lived in the way of thinking in terms of welfare cost of autarky, if I told you the welfare cost of autarky for 2 countries look similar, how far they can go has to be the same. But if I allow for these to be different in terms of potential gains, maybe how far one country can go could be different from how far another country can go. So what we want to compute is how much does each country gain by moving from what I observe on them right now to where they can possibly be in a world without any trade frictions at all, completely free trade kind of world. So the framework that we are going to use is sort of embed a multi-country trade model into a neoclassical growth model. Now, the inferences that we're going to draw are going to be common to lots of models, but this is very convenient to expose all the things that we want to talk about. And once we have done that, we're going to measure the potential gains in this model to go to a world with frictionless trade. So I'm going to call it later as trade potential, and then use that potential to construct an index for each country that maps every country into the same interval. In a way, I can talk about degrees of openness between them, because potential gains, the number could be vastly different across countries. I'm trying to map them into the same interval. Okay, so what we're going to deliver is a very simple measure. It's not going to be a function of just the home trade share. It's also going to encode the current level of GDP of the economy. So capital YI here refers to the total GDP of country I. And theta is, again, the trade elasticity parameter that we talked about when we talked about the welfare cost. So this measure that you can see, it's You might be thinking there's a units problem because lambda II is some fraction between 0 and 1. Yi is like trillions of dollars. But that proportionality constant is going to make sure this is unit free. So I'll spare you the algebra of what's all in that ugly proportionality constant. But trust me, this is going to be unit free. So you can see from the measure that potential gains could be different across countries. One is the standard reason, which is if the home trade share looks different across countries, the potential gains are going to look different. And you would have seen that in the welfare cost of autarky measure too, in the Arkelakis-Costino Rodriguez-Clare that I was talking about earlier. But it also recognizes that if the total GDP of a country looks different, the potential gains are going to look different. Okay? In addition to, so you have two countries with the same welfare cost of autarky, say US and Malawi, and they're going to have very different potential gains in the way we are going to construct the trade potential. Okay? All right, so here's a basic setup of the model. It's going to be very standard Ricardian model, much similar to what was used earlier in the measures of open, like welfare cost of autarky. So we can map this into, in the context of this model, what would the welfare cost of autarky look like? What would be the potential gains to frictionless trade look like? All will come from the same framework. So we're going to have n countries in this setup, indexed by I, as I mentioned already. So labor force of each country is going to be capital L. And the representative household in this country owns the physical capital and supplies it to the domestic capital market. So the way we have written it, this is a Ricardian model. Capital and labor are not going to be mobile across countries. When we do the calculations, those two factors of production are going to held fixed. Okay? The rest of it is sort of the trade component of it. So the trade component of it, there's a variety of goods that we like to consume. Denote that by xj. And these continuum of goods are produced according to various technologies. So I'm using CES function, not relevant for the welfare calculations. So I think I get a pass on this one today compared to yesterday. But so that this is straight out of Eaton and Cordum, the model setup. Or if you like a precursor to that, this is Eaton Cordum is the multi-country version. The two-country version would be done for Fisher and Samuelson in 1977. So each good is produced using capital and labor, and there's a productivity that's specific to the good. That's ZJ. So each country is going to have a productivity distribution that tells that country what's the productivity that it has for producing a particular J in the continuum 0 to 1. Okay? So country I's productivity distribution is potentially different from country J's productivity distribution, different from country L's productivity distribution, etc. So it's convenient for the purpose of figuring out the trade volumes in this setup to have that productivity distribution be distributed fresh A. Now, so what's useful about fresh A is the following. So if when people think about productivity distributions for a country, you can assume lots of stuff. You can assume log normal, you can assume particular beta functions or even fresh A distributions. So for trade purposes, that assumption of productivity distribution is very important. It's important because when it's a closed economy, you can get away with lots of these functional form assumptions, which you can track later on. But for trade, what you need to know is some properties of productivity across countries, not for a given country. So if I pick a particular good J, I need to know who's the most productive producer of that particular good J. So I ought to be able to rank fresh A distribution in country I productivity relative to country J's productivity to country K's productivity. So I need the cross-sectional distribution of productivities across countries to have like good extreme value properties. I need to be able to say who's the best producer or who's the least cost producer. So that's where fresh A is very handy. Okay, so this distribution has a property that this parameter theta, Ti raised to the power 1 over theta will tell you what's the average productivity in that particular country. So let's imagine what trade is going to do in this particular setup. It's a very Ricardian setup. Remember, the factors of production are not moving. The only thing that trade is going to do is kind of change the competitive advantage based on the frictions. Okay? So let's imagine the extreme case. The extreme case is each one in the room represents a country. We all have our own productivity parameter, Ti to the power 1 over theta. So theta is again picking up the trade elasticity. If we don't trade at all, we are producing the entire range of goods, 0 to 1. So what's the measured productivity in my country? Well, that's my country's T raised to the power 1 over theta. What's the measured productivity in your country? Your country's T raised to the power 1 over theta. Okay? Now suppose we open this up and we trade with each other. So how would this go? So I have to go in the direction of my competitive advantage. You would move in the direction of your competitive advantage. So that means the range of goods that you're going to end up producing, let's say imagine a world with less trade frictions than autarky, is going to be the ones that you're precisely good at. That means your measured productivity has to be higher when I reduce the trade barrier, and my measured productivity has to be higher when I reduce the trade barrier. So because we are both moving in the direction of precisely the goods that we're good at producing. That's the only action that's going to happen via what's the role of trade friction is going to do in this setup. Okay? The measured productivity is moving in the correct direction for both of us as we keep eliminating trade frictions. The complete elimination of trade frictions is sort of the extreme version of where we go to. Okay? The rest of it is kind of standard trade stuff. Iceberg cost for transporting transporting goods from country I to country N, with the normalization that the transport goods to yourself is going to be equal to 1. Okay? All right, so that's the model. So I'm going to get to kind of deriving our metrics of trade potential and trade potential index. So I'm going to go through like one main step. That's sort of the aggregation, which is once you do all the algebra and the model, what would real GDP in each economy look like? Okay. So I'm going to show you what that is. Once I have that, now I have to compute a counterfactual. The counterfactual is what does real GDP in each economy is going to look like when the world goes to frictionless trade. Okay? So that's a counterfactual. And then I'm going to tell you what these metrics are. Okay? Remember that the proportional formula that I showed you was based on observables. I didn't quite do any quote-unquote counterfactual calculations by putting parameters in and solving the model in a particular way. So that's where we are going to, something closed form just based on observables. Okay. So how do we do this? So it's a standard trade model. There's a bunch of trade flows occurring across these N countries. The bilateral trade flows are going to be a function of the cost of labor, so wage rate, cost of capital, that's the rental rate, and the barriers going from each country to the other countries, and of course the productivity parameter, the TIs that I talked about. Okay, so we can figure out the bilateral trade flows as a function of all these objects. The price index, so C is aggregator, that is going to be a function of the unit cost, the rental rate, the wage rate, and barriers to trade. Then rest of it is using the fact that since each production function was basically using capital and labor in Cobb-Douglas, other than this particular productivity, you equate the rental rate and the wage rate to the appropriate marginal products of the factor of production, and impose trade balance, 2 pages of algebra, and you're down to real GDP per worker. Okay. So the one thing that I want you to notice about this real GDP per worker expression is that it looks like what you would have written down in the neoclassical growth model, except with just one twist. The one twist is what shows up as TFP, AI, is an endogenous object. It contains something that endogenous to the model, and that's the home trade share. Okay? So this measured TFP that we get out of this trade model contains the exogenous productivity parameter TI, and of course the endogenous object, the home trade share. Now, this expression that I derived, which is similar to the neoclassical growth model, it's really nothing to do with the specific environment that you're in, meaning this expression holds up in autarky. This expression holds up if the trade frictions were whatever you make them up to be. This expression holds up if the trade frictions were 0. Okay? So all the range from autarky to free trade, you name a trade friction, that expression holds up. The only thing that's going to be different across all these environments is the home trade share. So as I keep going from autarky to some trade frictions to more trade frictions, some autarky to less trade frictions to no trade frictions, the home trade share is going to change. Precisely for the reasons that I talked about, because each of us are moving in the direction of our comparative advantage, we start trading more. So the lambda II is going to look different as I keep changing the trade frictions. So the autarky lambda II is the most obvious one. I don't even need a model to tell you what that is because I produce everything, so the home trade share has to equal 1. In free trade, I have to get you somewhere. Okay? So in general, remember that the home trade share depends on a bunch of other things that I've put into the model, the fundamental parameters of the model, the productivity technology parameters, and the endowments of these countries. Okay. So let's see how to put this real GDP per worker expression to use for the purpose at hand. So if you take that expression and you say you lived in autarky, then you know this home trade share has to equal 1. If this home trade share equals 1, then you know what is the autarky GDP per worker relative to my current GDP per worker, which is the observed GDP yi. And I know that's got to be equal to the home trade share raised to the power 1 over theta. I'm just using the expression for yi. And that's where Arkalakis, Costino, and Rodriguez-Clare got that expression. The welfare cost of autarky would be the change in income going from the observed equilibrium to autarky equilibrium. And the absolute value of that change is 1 minus the home trade share raised to the power 1 over theta. So that's where they got that. So it's valid in our setup too. As it turns out, this is valid in lots of setups. So the fundamental thing that I started with in terms of the bilateral trade shares, depending upon the unit cost for the various factors of production, the trade frictions, the productivity parameter, it ultimately leads in what's in trade parlance is called the gravity equation. That comes up in lots and lots of trade models. So this is not something very unique to Eaton Cortum specified with fresh air, et cetera, et cetera. So this expression you can get from lots of setups. Okay? So this is the welfare cost of autarky calculation from before. Now, how do we do with welfare gain that for each country by moving to a world with frictionless trade? Okay? I'm going to use exactly the same thing, the formula that I had before. Take the expression for income per worker. So income per worker in free trade relative to the current income is just a ratio of the home trade shares in free trade to the observed home trade share. Of course, what's in the numerator is a counterfactual. I don't know what that is yet. But we know something about frictionless trade. So in frictionless trade, the home trade share for each country has to line up with its share of world output in frictionless trade. Okay? So remember, Li is the labor force. So L times Y is the total GDP in that particular economy. So the easiest case to imagine here is, imagine you live in a symmetric world. Every country is identical. Then the home trade share in the frictionless trade for every country has to equal 1 over n. So all fraction of my expenditures is exactly 1 over nth of what the total expenditures are, is what I spent on myself. Remaining n minus 1 over n, I spend on everybody else. So that's a simple case of a symmetric country. So this is the case where it allows for asymmetry. So this is the home trade share. Now you can sort of see where we're going. We're almost there. So what I have is the home trade share as a function of income per worker or GDP per worker. I can stick that in the main formula talking about the change in income for going from an observed equilibrium to an equilibrium with frictionless trade in the world. So I got a vector of GDP per workers on the left-hand side, which is a function of a vector of GDP per workers on the right-hand side. We know how to solve this, and that's what gives us this potential. So the potential gains to frictionless trade is going to be a function of a whole vector of GDP per worker and a vector of home trade shares. And it's going to depend on the observed home trade share in country I relative to GDP in country I. So everything on the right-hand side here is observable. Left-hand side is the object that we were interested in. How much do I gain to go from the current observed equilibrium to an equilibrium in which the world is in frictionless trade? Okay? So the right-hand side is entirely observable. Okay? So remember in this calculation, I didn't do the usual brute force one. We all know how to compute this particular counterfactual. If I told you the structural parameters, which you can infer by using data today, then you would have used the structural parameters and changed the frictions from, say, autarky to frictionless trade number, say barriers are equal to 0, or you could have gone from the current level of barriers to a level where barriers are equal to 0, and you would have computed the counterfactual. So we all know how to do that by plugging into the computer. This is telling you that you have an answer just based on current observables. You don't even need to switch on the computer. So we have the answers based on observables. All right, so a couple of things to note about that particular formula that we had. So remember, the right-hand side is all observables. So the observables that we are going to pick up from the data are home trade share and total GDP. Two things we're going to pick up from there. So the trade potential, that's what you can gain from going from the current observed equilibrium to a world with frictionless trade. All the things that you know about technological differences or endowment differences, etc., are completely described by this vector of total GDPs and the vector of home trade shares. So I did not touch anything about, okay, what's the trade barrier in country 1 relative to country 2? What's the productivity parameter in country 1 versus country 2? And endowments of country 1 versus country 2. It's all summarized in this vector of total GDP and vector of home trade shares. And we picked all those differences up. Now you can see from the formula a couple of things. If I hold fixed the home trade share, so again, go back to the Malawi versus US example, they had the same home trade share, then a poorer country will have a higher trade potential. So in this case, Malawi would have a higher trade potential. That is, they have much more to gain by going from their observed equilibrium to a frictionless trade equilibrium than what US would gain to going from its observed equilibrium to a frictionless trade equilibrium. So all of a sudden, you can see how our openness measure is going to look different than the welfare cost of autarky measure. The welfare cost of autarky measure was exclusively dependent on just the home trade share or volume of trade. Now we've brought in one other difference between the countries, and as long as they're different, it's going to have potentials looking different. Yeah. Yep.
So if you're in autarky or in an open trade, the dispersion of the distribution is the same.
Correct.
Of the relative.
Yep.
But I think that's kind of counterintuitive because if you're in an open economy and in a balanced model with respect to the more competitive trade.
So the question. So first of all, the productivity distribution parameter in Mellits doesn't map 1-for-1 into the trade elasticity parameter. So here it maps over into trade elasticity parameter. So you shouldn't confuse this data with the productivity distribution parameter in Mellits. They're two different things. Correct. No, the question is the implied trade elasticity is that is structurally invariant to policy or not invariant to policy? That's it. That's the key question, right? If it's invariant to policy, then you can use this trade elasticity to do the calculation, which is exactly the argument that made in the paper that I showed you earlier, Arkalakis, Costin, and Rodriguez-Clare. They in fact show that particular trade elasticity parameter is something that you can use to calculate the welfare cost of water. That's not even something that we have innovated. It's already done. Okay? So the productivity distribution versus trade elasticity are two different objects. In this model, it maps into the same thing. So the fresh air distribution in Eaton Cordum, it maps into the same thing. In Mellits, it does not. Okay. All right. So, yeah. So in the trade potential, two countries with the same home trade share could potentially look different as a result of other differences between the countries. Okay. So now, let's say for a minute we go to the data and compute all these trade potentials, and I'm going to show you some numbers in a few minutes. Out of this, I'm going to compute what's called a trade potential index, what we call trade potential index, which is going to map every country into a point in a 0-1 interval. So what do we mean by a trade potential index? So we want to somehow think about this welfare cost of autarky relative to the maximum possible gains that the country could possibly have. So that is, we want to think about a distance between autarky and the frictionless trade equilibrium for country I, since we're allowing for the possibility that distances are not the same across countries, which was our starting point or our departure point. We're going to somehow map this welfare cost of autarky measure relative to this full distance, the maximum possible gains that you can get from autarky to frictionless trade. So that's this particular calculation. So take the income change from observed equilibrium to autarky and think about how large that is relative to the income change between autarky versus frictionless trade. Okay? So that's the entire interval. Now you can sort of see we have solved for all the objects over here, almost. So think about dividing the numerator by the observed income yi, denominator by the same observed income yi. I know all of those ratios from what I showed you earlier. So that boils down to what's the welfare cost in the numerator, and the denominator is sort of the trade potential minus this home trade share raised to the power 1 over theta. So I just used the calculation that I knew in terms of ratios to map it into this number. Now, this has some nice properties. It's convenient because if the countries were in autarky, this index should yield a number 0. The countries were in frictionless trade, it should yield a number 1. Okay? So I can place a country which has some trade frictions somewhere in between 0 and 1, okay? According to this particular trade index. So that's going to be, so pictures I'm going to show you are calculations of our trade potential and calculations of the trade potential index. And then we're going to do the comparison to welfare cost of autarky. So that's sort of where I am right now. Okay. So now in terms of the data that we use. So it's very straightforward. Open up Penwell tables. We're going to use the benchmark year 2005. We're going to drop countries with missing data. I have a typo over there. We dropped countries with import to GDP ratio greater than 1, not the one less than 1. If I did less than 1, we would have no sample. So we have 160 countries in the sample as a result of this selection. And we have set the trade elasticity to be 4. So there are like estimates backing that up. So it's listed in the paper. You can look that up. We can do the other calculations with other elasticity. So I'm going to show you numbers with this elasticity. So first picture is of trade potential. So let me remind you what the trade potential is. You take a country from its observed equilibrium and ask the question, if the world moved to frictionless trade, what would be its income in frictionless trade? And we have computed that for every country using the formula that I just showed you, how you derived it using just observables. Okay? So two things I should mention in this particular graph. On the horizontal axis is observed GDP per worker, 2005 Penwell table 8.1. On the vertical axis is the ratio of potential GDP divided by the data, observed GDP per worker. Okay? And the scale is on base 2. So this is running from 1 to 1/2 to 1/4 on the horizontal axis. On the vertical axis is going from 1 to 4 and 8. Okay? So the US is about 1.5. That is, frictionless trade GDP is about 1.5 times its observed GDP in our calculation. Malawi is about 7.5. Okay? So Malawi is somewhere over there. So its total GDP is much lower. It's a much poorer country. Its potential gains are larger. So in general, the systematic thing that I want you to pick out of here is that the potentials are large and they're larger for the poor countries. Okay? I think the median here is something like 5 or so. Now on the same scale, I'm going to plot the welfare cost of autarky. Okay? This is exactly the Arkalakis-Castañón-Rodriguez-Clare calculation. If you plot the welfare cost of autarky, you can sort of see it's awfully close to 1. Again, going back to our measure of what would be an open countries are the ones that are farthest away from 1. Okay? And you would come across countries in that range. US is somewhere over here. Malawi somewhere over here. Their welfare cost of autarky is awfully close. Okay. So between those two pictures, you can draw some implications. Just because you saw a similar welfare cost of autarky doesn't tell you much about how much the country is open, or in other words, it doesn't tell you how much about how far the country can go to frictionless trade, or how much it can gain if it eliminated all of the trade frictions. So the distance for each country is potentially different between autarky versus frictionless trade. So if I compare US and Malawi, the welfare cost of autarky is practically the same, whereas the trade potential for Malawi is 5 times that of the US. Okay? So even though they look very close to their autarky GDP, the distance that they need to travel to frictionless trade are very different in the two countries. Okay? The other thing that I want you to take away from that picture is that just by looking at the welfare cost of autarky and concluding the world is an autarky, because all of them have very low welfare cost of autarky, is a wrong inference. But the combination of the two, you could conclude the world is approximately in autarky, meaning the distances for all countries to the other extreme is fairly large. The distances to autarky is fairly small, and that's what leads to this inference that world is approximately in autarky. Okay, so the other calculation that I promised was the trade potential index. So now this is the one that takes the welfare cost of autarky and maps it relative to the maximal possible gains. So you take this interval between autarky GDP and free trade or frictionless trade GDP and place a country somewhere in that interval. And that's the index we're going to construct so that every country is in the interval 0 to 1. Now, this looks awfully low as well. The trade potential index says they're all hovering around 0. Few countries are different. But the part to notice over here is that if I were to rank countries based on this index and ask, okay, which countries are more open relative to others, I'm going to come up with countries that are farthest away from the horizontal axis, right? Now, all of a sudden, in the top 10 countries, I'm seeing USA. Okay? Remember, US was not one of the top 10 most open countries when we looked at the measure of openness based on welfare cost of autarky. In fact, I was 80% wrong. Now, so this is just a zoomed in version of the previous picture. I haven't done anything other than change the axis. Instead of 0 to 1, it's just 0 to 0.3. Now you can see sort of the top 10 most open countries are going to line up on the right-hand side instead of the middle income and poorer income side. Okay? So the first thing to note is how come we could see US in the top 10 most open countries according to our trade potential index, whereas the welfare cost of autarky doesn't put it in the top 10. It was lining up very low welfare cost of autarky with the trade potential index puts it much higher than the other countries in terms of getting into top 10. So first, as I told you earlier, Malawi and US have the same home trade share. US is not exceptional when it comes to home trade share. In fact, all the countries were kind of lining up close to 1 anyway. The reason why we get this is that trade potential for the US is small. So what I want you to imagine is that if the US went to autarky according to the welfare cost of autarky calculation, the cost is very small. Now, suppose US goes to frictionless trade, what does it gain? Well, it's possible the gains are also very small. The US is very productive at lots and lots of things. In terms of what it can do, the fact that you observe a large home trade share in this class of models, you should not infer it's because of huge barriers to trade. It could be because you are a high productive country, right? Because that's sort of the identification problem in terms of the home trade share. So there's a lot of information in the bilateral trade that helps you figure out which one is due to frictions and which one is due to barriers. So structurally, we can definitely identify this. But here, the part to keep in mind is the reason why these two metrics show you different things is because you can have countries who are very close to autarky but not that far away from frictionless trade either. And there could be some countries who are close to autarky but very far away from frictionless trade. And that's where this distance between autarky versus frictionless trade is important. So that mapping into 0, 1, you have to think of welfare cost of autarky relative to that particular distance, how large it is. So this possibility tells you that by that metric, US is a very open country. Because its welfare cost of autarky is small, the whole distance is small too. So relative to that distance, US doesn't look that bad. So this is where 80% of my guesses would have been right. On the previous metric, I was totally off. So the right-hand light column is our ranking by the trade potential index for the top 10 most open countries. And left is the same ranking that I showed you earlier, the welfare cost of autarky. So there are 3 countries that show up on both. I wouldn't have guessed one of them anyway. But the other countries look more normal in terms of what you might have guessed as 10 most open countries. Okay? So one question to ask at this stage is that, okay, so we have a measure of openness based on our constructed trade potential index. You could have thought about a measure of openness the old way, which is volume of trade, which is equivalent to thinking in terms of welfare cost of autarky because they map 1 for 1. And if there is a way to figure out the underlying trade frictions that is consistent with the observed trade flows, how do these two measures of openness correlate with those underlying trade frictions? So how would I go about doing that? For this, I need to infer the structural parameters. Okay? All right, so I have the model. I have the productivity parameters I need to estimate. I need to figure out the trade frictions that make the trades flow across n countries with each other. So I have access to the bilateral trade matrix. So what we're going to do is take the 2005 data, use the GDP data and the trade data, so in this case imported GDP, and we're just going to infer one trade barrier per country. We can do something more complicated. We could have inferred out of this bilateral trade share matrix, you could essentially infer the bilateral barrier matrix. So we could nail it literally country by country across pairs, but let's take the simpler approach. So one trade barrier per country. So by construction, we have enough things to identify exactly the barrier and the parameters using GDP and the trade data. We have, to do this calculation, of course, you need to know the capital share and the trade elasticity. So we took those, data was already set equal to 4. The capital share, we know from lots of development accounting exercises, is hovering around 1/3. So we're going to stick that in. Okay. Once you do that, you can figure out what that barrier is, and I've plotted that against our trade potential index. So on the vertical axis, the log of the trade potential index. On the horizontal axis is the trade cost that we inferred from calibrating that our model to the 2005 data. Now, this is at least persuasive that our trade potential index is negatively correlated with the trade cost, so we're picking up something. So a couple of numbers to note. If I look at just the straight raw correlation, that's about 0.94. It could be spurious, but after conditioning on income, we look at the correlation, it's still very strong. It's almost 90%. Okay? So our measure of the trade potential index, which is our measure of openness, correlates nicely with the measure of trade cost that you would infer from a model that's consistent with the trade flows and GDP per worker. Okay? So that's how we inferred these particular trade costs. Obviously, we already told you it's easy to compute. It clearly summarizes the underlying frictions to trade. Now, the relationship that we have is much stronger than had you plotted the same graph with the welfare cost of autarky on the vertical axis and the trade cost on the horizontal axis. the correlation conditional on income would be less than 30%. So the welfare cost of autarky measure of openness does not correlate well with the underlying trade frictions, at least not as well as ours does with the underlying trade frictions. So that's a sense in which our measure of openness is sort of a better story to go with. And I'll conclude on that. So we derived a new measure of openness to trade. I showed you what the trade potential looks like. It's the gain from the observed equilibrium going to the free trade equilibrium. And use that to compute the trade potential index. It's easy to compute. Its potentials are very large for poor countries relative to rich countries. The world as a whole is approximately an autarky, given that the potentials are large, but the welfare cost of autarky is small. According to our index, at least, the rich countries look more open relative to poor countries, and our index correlates very well with the trade cost that you could infer from a model that's consistent with the trade flows and GDP per work. And I'll stop. Yeah. You're asking a practical question. All right. Never good in keynote speeches, but okay. So what we derived was a case in which you can talk about the home trade share under frictionless trade, which is an implication of lots of trade models independent of the details. The idea that it's equal to its share of GDP relative to the world share of GDP in frictionless trade was an easy object that we could use to compute. If you want to think about trade barriers which are somewhere between infinity and 1, you can certainly compute that, because you can take the calibrated trade costs and set it to whatever number you feel like and compute the counterfactual. So that's not a problem in this class of particular models. But the gains that we use to construct the trade potential index, that won't be valid. So if the objective is to just to calculate what is the gain for a country as a result of going from its current level of trade frictions to some other level of trade frictions, that's easy to do. But there's no closed form formula for that. There's no analytical implication of that other than switching on the computer and doing the standard counterfactual.
Yeah, I just wonder, you have capital for that capital, so how do you include the capital risk into the y-axis?
So for the talk today, to talk about the trade potential and the trade potential index, I didn't have to take a position on that at all. I don't need to know what's capital, because I gave you all the answers in terms of total GDP and the home trade shares. Okay? But when I did the calibration, I have to do some sort of development accounting to infer the technology parameters, right? So the technology parameter is sort of like a solo residual that you calculate from the expression that GDP per worker is a function of TFP, measure TFP, and capital per worker. Measure TFP is a function of home trade share. So I need data on GDP per worker, home trade share, and capital labor ratio, all of which I can pick from the Penwell tables. And that tells you what's the productivity parameter. That's where I use the capital. Otherwise, for the trade potential index and trade potential, I didn't use the capital stock at all.
In general, GDP is not equal to GDP income.
GDP is not equal to what? It's not equal to total income. So do you have something like gross national income or some other measure you have in mind, or I'm not sure? Oh, the mobility of capital. Oh, that doesn't matter, because in some sense, GDP is the factor payments to factors of production sitting in that country, independent of ownership, so to speak. So you can calculate GDP that way. So the expression in a world with you're relying for capital goods trade, the expression is going to look similar, but the capital stock would involve traded components. So we have to account for that. So we didn't do all that over here because there's no separate capital goods being created. Okay? But that can be done. That's a fairly easy part. Yeah. Thank you.